Hello and welcome. It is time once again to try to fix something, and today on the workbench I'm going to be taking a look at another PS5 power supply. And this one is an ADP-400FR. So yeah, this is the one that's currently kind of hard to come by. It's used in the most current version of the PS5, and there's not many of them out there. New ones are like $200. Broken ones are still ridiculous, but they're just hard to come by. But this one I bought from off an eBay listing, and it was listed by one of a subscriber to my channel, so I knew it was coming up. But it has a strange problem. It's not totally dead. He actually included a note with it, kind of describing the problem. It apparently tries to work, but falls down when it comes time to power the actual PS5. So basically, it seems to have a problem delivering power to a load, to a significant load. So we're going to put that to a test first thing and just see if that's what it's doing. I have my load set. It's not on. Let's see. On. What am I set on? 1 amp. Okay, we're set for 1 amp. So let's give it some AC power. See what happens. She does start up and run. No problem. 11.9 volts. Looking good. All right, let's increase this load. 2 amps. Dropping a little. 3 amps. 4 amps. 5 amps. Some strange things start happening then. Looks like it's cycling up and down if you look at it. 8 volts, 11 something, 8 volts and 11. So yeah, this is probably supposed to be capable of 31 amps at 12 volts. So yeah, that I think will not power a PS5. If I go to 6 amps, yeah, you can see more. So we have a problem delivering a significant load. Anything over about 4 amps looks like, and we're unstable. So this is going to be an interesting one. Let me get it opened up, and we'll get on into this repair. I won't bore you with me prying this thing apart. It's always fun. Well, our covers are off the power supply, and I think where I'd like to start testing this is seeing what kind of voltage we're getting across those filter capacitors. It should be about 400 volts, 395, 397, something like that. And I'm wanting to see what it's doing when this load oscillation happens. So I'm set for 4 amps right now. Let me go ahead and fire off my AC. My load is connected. I think I've got it turned the right way. Yeah. She's up and running. Oh, look at our voltage across those capacitors. 276 volts. When I've got a 4 amp load on there. How is this thing even running? That should be 397 volts. So that's our power factor corrector is not boosting like it should. It's trying, because if it wasn't doing anything, you'd have about 160 or 70 volts. Because I'm powering off 120 volts AC. So yeah, you'll get like 160 or 70 volts filtered DC, rectified and filtered. So anyway, the power factor corrector is trying to run, but it's struggling. What if I turn the load off altogether? All right, even with no load, we're only getting 340 volts. So yeah, it's not really doing its job very well, is it? Turn the load back on, and we drop down. That's going to be our basic problem, is our power factor corrector is not giving us the boost that it should. Okay. Which, on this design, on previous designs on the PS4s, you had an IC that just did power factor correction, and then you had one that handled the generation of the 12 volts. Well, on this one, the ADP-400FR IC on the back does it all. So it's a power factor corrector and the DC-DC controller. So that's a good possibility. Those chips do die. Could still be something, I suppose, in the feedback circuit. I do find it odd, though, that it doesn't shut down. Because it's not generating the proper boost voltage. And it will shut down if it's too high, I suppose, but it should usually shut down if it's too low, I would think. So that's a little confusing. But maybe we'll take a look around that ADP-53. Maybe we can find something. Let me get this thing powered off, and I will drain these capacitors, discharge these capacitors, and we'll make some checks around the ADP-53. All right, we're going to get started making some diode checks around this ADP-53. I want to put my red probe on the common point, which is the negative terminal of those large filter capacitors. And let's just start with pin 1. I have discharged the capacitors, by the way. 0.7, 0.57, that looks right. 0.64, that's a little lower than what I have in my records. 4 is ground. 5.66, that's not too bad. Maybe 6, 6.5, 6, that looks fine. 7 is no connection. 8, 1.48, that's normal. 9 is also 1.14, that looks normal. 10, 1.13, that looks normal. 11, 492, that looks pretty close. 12 is no connection. 13 is 0.705. That's close. 14, 627. Close enough, I think. This is 15, 702. Yeah, that's right there where it should be. And 16. All right, all that looks fine. I don't see any problems there. Well, it just means the chip is not shorted, which we kind of knew because it is trying to work. Let's look around. I know I've had trouble in the past with these resistors right up here that are, the feedback. I don't really think that's the issue this time. Let's go to resistance mode. And it's really hard to check these things in circuit though. Yeah, getting negative values because if there's any voltage on these filter caps at all, there's not a lot of current that goes through these resistors. They're 7.5 meg, when you're checking with your meter. So yeah, that will make you think that there's a problem. I'm going to say they're probably good. They don't look burned. They don't look scarred in any way, damaged. So yeah, we can't get good readings on those. We'd have to lift one of them to get readings on them. And we'll do that if we have to. But I think for now, I think I'm going to leave those alone. And look, but that is the main feedback for this chip. That's where it should be coming back in. Best I can remember, it comes, right here through these resistors, right underneath there. Right between it. It disappears, you can't see it, but it's actually splitting right there under that white paint. And it goes over here down to a small MOSFET, and it goes over here across this Zener diode, which is an 8.2, I believe. And then there's like a 90 some, right close to 100K to ground right there. Let me make sure that's in the picture. And then we go into right here on pin 2. And that's its feedback. That's how it is looking at the voltage that it's developing. So if it has an accurate feedback, why is it not trying to boost that voltage anymore? Of course, I've seen this MOSFET here. This is the other side of it. We'll follow it on down. Comes right down through here. This is that same voltage after those 7.5 megohm resistors. Jumps over that 0 ohm jumper right there to right here. And this is part of a shutdown circuitry that is triggered by this opto-isolator right over here. So, and that is an EL1013. And I've seen those be damaged in the case of, like, bugs and stuff, but that doesn't seem to be the issue here. Getting 100 k ohms across there, which is not going to be across this, it's going to be across something else in the circuit, because this should read infinite. And that's the best way to check it, is just lift one of these legs and check across it, and you should get, infinite resistance. And I don't imagine this is going to be shorted, because if it was, it'd just be shutting down. Oh, this is looking good. Is this just going to be a bad ADP-400FR? It doesn't seem bad with diode checks, but diode checks aren't going to tell you everything. Just tell you if it's dead, shorted. I don't see anything burnt. There's like some dirt on this board. Looks like soot, but I guess it's just dirt. That may be the best place to start, is just swap that out. I do have some chips to put on there. There's not going to be any obvious burn marks on this one to say, hey, here's the problem right here. Because no roaches involved in this one. Okay. All right, I think what I'm going to try first, I'm not going to jump straight to the ADP-400FR. Let me show you this diagram I drew earlier on another repair. That boost sense, comes through these resistors right here, limited by that Zener. There's that 95K resistor to ground. And it can be pulled to ground right here, which causes a shutdown. And it's not shorted to ground, because if it was, it wouldn't be running at all. But I'm just curious if there's something going on either here or here that is loading this voltage down. Not sure. I just want basically to eliminate this. So I'm going to remove this transistor, this Q34, which is a 2N7002 of some type, and just to basically eliminate that from the circuit. Because at that point, all there really is the feedback resistors straight into the chip. There's not a whole lot else going on. So let me do that. And while I have the hot air out, I may go ahead, I think, and lift one of these resistors, just spin it around, so we can get a good check on these two resistors, just to eliminate those while I have the hot air out. Actually, now that I think about it, I'm probably not going to use hot air. I'm just going to use the soldering iron and maybe some low melt. I've had a bad problem of these boards wanting to popcorn with hot air, so I try to avoid using the hot air. So I'll try to use the iron only. well, I have lifted, one of these resistors so I could check both of them since they're in series. And they check perfectly fine, no problem. And measuring on this pin here, pin 2 into that IC, measure, about 100K, a little less than 100K, which is probably this resistor to ground right here. So that seems fine. I have removed Q34. Just taking that out, just disable that shutdown, just to make sure that's not causing some kind of a problem with our divider network, for our feedback. And let's just see if this has had any effect whatsoever. Let me give it some AC voltage. We are metering our boost voltage, which looks to be 395. That looks normal, but we're also only at 4 amps right now. So what if we inch this up? Okay, 5 amps, 6 amps. All right, 7 amps, and it looks like it's starting to fall off. That doesn't look right. 8 amps. But it is acting differently. At 9 amps, we're down to 353 volts or so. That's not normal. That should maintain, right at 395 volts, let's say. That's what they seem to usually be. So I think we still have a problem. Yeah, 10 amps, we're down to 330. So I think we still have an issue there. And I think I'm going to go ahead and change out that ADP-400FR as my next stop. Okay, there's not a whole lot to this circuit as far as feedback and generating that boost voltage. Not a whole lot to it. So, all right, that's my next stop then. I'm going to go ahead and change out the ADP-400FR. And then I'll also probably put that little MOSFET back in that I pulled out, which is, I'll focus sometime. This one, Q34. I'll put that back in there. Well, our ADP-400FR has been changed out. Our Q34 has been reinstalled. Let's see if this has made any difference. Let me move this. Oops. AC cord came out. Move this for everything's in the picture. All right, our load is on. Let's see what we get. All right. 397. That looks good. Of course, we're only at 3 amps load right now. What happens if we increase this load? 4, 5, 6, 7, 8. Yeah, this is looking much better. 9, 10. 10 amps. And she's running pretty good, I'd say. I think we're generating a good 12 volts. This is going to show a little low because of the loss across these wires I have. They're not the largest. Maybe we can get a better reading here with my meter. Not sure if I can do this one-handed though. Let's see. Positive. I'll check it right here on the terminals. 11,935. So yeah, little loss across those leads there. But at 10 amps, that's not bad. Our boost looks like it's working well. Okay, I think that's going to be about the end of this one. That was a rather simple fix. Just change out the ADP-400FR, and she is running again. Seems to be pretty solid. All right, well, I hope you enjoyed that one. Thought it was somewhat interesting or educational. If you did, please give me a thumbs up, and I will see you in the very next repair. So long for now.